Hi, welcome back to College Algebra. This is week 9, and we're going to be talking about how to add, subtract, multiply, and divide rational expressions. We'll cover 5.2, 5.3, and 5.4. And please look over the measurable outcomes for this week. Okay, let's talk about how to multiply and divide rational expressions. So you remember when we learn how to multiply fractions, it's very simple. You just basically multiply the numerator and then also the denominators. So for example, 2/3 times 5/7, you simply multiply 2 times 5 and then 3 times 7. And so same thing for rational expression, we just multiply straight across. 2x times 5z is 10xz, 3y times 7 is 21y. Now it's possible that we might also want to simplify the expression before we multiply. So for example, in the case where you have 710 times 15 over 21, we can factor out some of these numbers and then cancel. For example, if I factor out 15 into 3 and 5, and then 10 into 2 and 5 and 3 and 7 for 21, then we notice that the 7 cancel, the 3 cancel, the 5 cancel. So canceling will help us simplify before we multiply to get the final answer. So this is the same for a rational expression. We want to be able to factor so that we can make some cancellation and then simplify. So for example, here's the multiplication of two rational expressions. Notice that if I factor the 5 from the top, the numerator of the first term, I get 5 times a minus b. So 5 is the greatest common factor, so I factor it out. 10 is 5 times 2. And then notice a squared minus b squared. This is one of those special expressions, the difference of square that can be factored into a minus b, a plus b. And now I can try to cancel. The 2 can cancel, for example. The 2 cancel, the a minus b cancel, the 5 can cancel. You cancel all those, and then finally, when we to get the final answer, we multiply whatever is left. And so notice on top that everything is canceled, so you have a 1 left. 1 times 1 times 1 is 1. And on the bottom, a plus b is left, so we have 1 over a plus b. This one's a little more complicated, but it's the same idea. We just gotta factor everything and then try to cancel. And so again, on top here, I factor out the 4. That's the greatest common factor. And then at the bottom here, take out a 2. And then on top here, this is one of those quadratic that we talked about earlier, factoring quadratic. So you can use either the AC method or try and error, but you get so 2w times w is 2w squared, and then this is minus 15p squared, so this is minus 3p plus 5p. And again, you can check that if you cross multiply, you get the positive 7wp. And then you can also factor out the bottom term here into, take out the 3 and then from the expression. And then now we can do some more factoring. And that is, notice that this is a difference of square. We can also factor that into w minus 5p, w plus 5p. And then finally at the end, we can do all the cancellation. So these terms cancel, the 2 cancel, these terms match up, they cancel. And then finally, multiply whatever is left, and then that's the final term. Now when you divide, you remember that when we have two fractions we divide, we simply multiply by the reciprocal of the second fraction. So if I divide this, I take the second fraction and I flip it, and then I multiply just like before, and I cancel just like before. So again, if you have a division, you just multiply by the reciprocal. And so for example, here's a rational expression divided by another rational expression. And so again, I'm going to multiply by the reciprocal. And so the way I do that is, just like before, I try to factor and then try to cancel. And in fact, this 8t cubed plus 27 is actually one of those sum of cubes that we saw, one of those formula that we can either have memorized or look it up. But we can use that formula to factor the top part, the sums of cubes, into the following here. And then this is the difference of squares, so I factor that as I did before. And these are just quadratic that we can factor into So this is a quadratic that can be factored, and then finally we can try to factor this, but this cannot be factored. Okay, and then now again we try to cancel as much as we can. The thing that's not obvious from this, so this obviously cancel with that, this cancel with this term, but notice that these two terms are opposite. 2t minus 3, 3 minus 2t, because they're opposite, you can cancel and get -1. And so we saw that in one of the previous lecture. And then we have this left at the end with a negative. And so we either can leave the negative outside there, or we can just distribute that into the top, and then divide by 1 doesn't do anything. So the final answer could be -t plus 1, or distribute the negative into -t minus 1. Okay, let's talk about how to add and subtract rational expression. So just like fraction, adding and subtracting is actually harder because we have to have a common denominator. So for example, adding fraction have the same denominator, you can just add them. And subtracting with fraction has the same denominator, you can subtract them. But if they don't have the same denominator, then you have to do more. So we'll see that in a second. So again, same denominator at the top, and then keep the denominator. So 1 plus 3 is 4, divided by 8. Again, same denominator, so just at the top. And you can try to factor, but we can't factor this, so you can't cancel too much there. And this one, the same thing, same denominator, so subtracting. Notice this is a common mistake that people make, is that this negative is subtracting the entire expression, so that negative needs to be distributed into both the x and the 12. So minus x minus 12. That's something that we want to be careful with. And then again, just try factor and then cancel. Okay, now when you have two fractions that have different denominator, we have to try to find a common denominator. In fact, the best denominator to find is the least common denominator, or the LCD. And so, for example, you have 1 over 20 and 1 over 8. 20 and 8 are not the same, so we have to find the least common denominator, which is 40 in this case, so that we can find a way to make the denominator be 40, and then we can then add or subtract. And so to understand how this works, let's look at this example. If I factor out 20 into prime factorization, 2 squared times 5, and the same thing for 8. In other words, factor them so that you can't factor them anymore, and group them in terms of powers. The way you find the common multiple, the least common multiple, or least common denominator of these terms is to basically pick out powers, common powers of the highest term. So for example, 2 squared here, 2 cubed, so you pick the one that has the highest power, which is 2 cubed. And the reason is because we want something that is a multiple of both. So 2 cubed certainly is a multiple, has all the term we need from this side, and then because 2 cubed is bigger than this, it's a multiple of this side as well. So you want to find multiple of both, and we want to find the smallest multiple, and so if we pick out the highest term of each of the prime factorization, that will be sufficient to find the least common denominator. So let's see some examples here. So let's find the LCD of these expressions. So again, 12, 18, and 30. So let's factor everything out into prime factorization. And then we just pick the highest power of everything. So 2 square here, 2, and then 2. So that means we pick the 2 square. And then 3 square, and 3. So I picked the highest, which is 3 square. And then there's a 5 here. There's no 5. There's no 5. So you pick the highest, which is a 5. So you pick the highest power of every term, and then multiply them, which is gives you, so 2 squared times 3 squared times 5 is 180. That's your LCD. Okay, same thing for this one. We gotta factor everything out, and so notice that you have a 2 here and 2 to the 4, so you pick 2 to the 4. X cubed, x, so pick x cubed, and then y square, so you pick y square. Z, there's no z, so you pick the z. So you pick those, you get, this is the LCD, 16x cubed y squared z. Again, the reason why this works is because 16 is a multiple of both, because we pick the highest power, so it's a multiple of here and a multiple here. X cubed, we pick the highest power, so it's a multiple of x and a multiple of x cubed. So basically, kind of pick the highest power so that we have multiple of both. Okay, let's find the LCD of these terms. So again, we gotta factor everything out. So This one factor into x plus 4, x plus 5. This is x plus 4 square. So now we again pick out the highest power. X plus 4 square, so you pick x plus 4 square. X plus 5, there's no x plus 5 here, so pick x plus 5. So that's the LCD. And then for this, we notice that these are opposite. So x minus 3 and 3 minus x. And so you can factor out the negative 1. So now we can now pick out the highest power. And that is x minus 3, x minus 3, so pick out that out. And then you want to take a negative 1 or not. So that's either one would be fine. Take negative 1 or not. That would be okay. Okay, and then so now if we want to add two rational expression, again we got to find the LCD, and then we want to multiply by the appropriate term so that both fractions have denominator equal to the LCD, and then we can add or subtract the rational expressions. So for example, these two terms, x minus 2, there's no x minus 2, so you pick x minus 2. X plus 1, there's no x plus 1 here, so you pick x plus 1. So picking the highest term means picking both of them, because x minus 2 and x plus 1 have nothing in common. Pick both of them. That's the LCD. Now to add these, we gotta make sure we multiply by the first term by x plus 1, so that we get the LCD. Notice I have to multiply by x plus 1 both in the top and bottom. This essentially is multiplying by 1, so we're not changing the fraction. On the other hand, on this side, we multiply by the top and bottom x minus 2, so that again we have the LCD. So you multiply by whatever to get the LCD on the denominator. And once you have that, then now, because these have the common denominator, we can now add the terms, and you add it by distributing and then combining like terms. So distribute this, distribute that, and then combine like terms. 3x plus 5x is 8x. 3 minus 10 is minus 7. So that's how you add rational expressions. So again, look over the direction here. This is basically the steps we went through. Here's another one. Trying to find the LCD, right? 7 here, and there's no 7, so pick 7. B and B square, pick B square. So LCD is 7B square. So I need 7B square on this, so I need to multiply by B to get 7B square. B in the bottom and top. I need 7B square, so I need to multiply this by 7. When we have that, now common denominator, I can combine the like terms on top, and then that's it. So subtracting is similar. Factoring everything out. So factor the bottom to this. The bottom here to be 2 times t plus 6. The LCD, well, t plus 6, so pick out t plus 6. There's a 2 here, there's no 2 here, so pick out the 2. T minus 2, pick that out as well. So the LCD is 2 times t plus 6, t minus 2. So again, I need to have the bottom to have the LCD, so this needs the 2, multiplied by 2, top and bottom. This term needs a t minus 2, do the same thing. And now everything, the LCD is at the bottom now. Now I can combine the top by subtracting. Again, when I subtract, I need to subtract the entire expression. So when I distribute, I need to distribute to both of these. And so distributing the top, and then simplifying, combining like terms. 6t minus 5t is t. And then minus 4 plus 10 is plus 6. And then notice I can cancel this. So cancel that again. So I have this as the final answer. So again, please look over these notes. If this is fast, then just you can watch it again or look over your notes carefully. Okay, then this one is the same, except that now we notice these are opposite. X minus y, y minus x. So one way to do this is to kind of factor out a negative 1. So for example, if I factor out the negative 1 or multiply by negative 1 on the right side, then that will make this be the same as that, and then now they have the same denominator, and now I can combine the terms on top. So x squared minus y squared, and then factoring. This is sums of squares. Sorry, difference of square. So I factor that out. Another cancellation. Here's the final answer. Yeah, so a lot of these problems you just gotta have a lot of practice with factoring and then finding the LCD, and so your what work homework will help you do some of that. Okay, finally, complex fraction. So complex fraction is basically when you have a fraction that has fraction within it. So here's a fraction that has fraction on top and on the bottom, and same thing with this one. There's fraction above and below. So these are complex fractions. So there's a couple ways of simplifying a complex fraction. Method 1, let's talk about method 1. Let's do by example. So method 1 is basically try to combine the fraction in the. So first of all, we're going to try to combine the fractions in the numerator and denominator separately, and then try to combine them and see if we can try to cancel anything after we combine. And so notice that again, we can combine them by finding the LCD. The LCD of the 4x and 2 is just 4x. So I need to multiply the second part by 2x to get the 4x. And then on the bottom, the LCD of 2x and 1 is just 2x. So I multiply the left term with 2x as well. And now when I combine like terms, again I have a fraction divided by a fraction, so I multiply by the reciprocal. So again this term stay the same, but the bottom term will get flipped. And then I can do some cancellation before I try to multiply. And notice these are opposites, so that cancels as well, give you a negative 1. 1 minus 6x, 6x minus 1, they're opposite, so you get negative 1 out of the cancellation. And then we finally get negative 1/2 at the end. So again, this method 1 is essentially combining the top and the bottom separately, and then at the end, when you divide, we're hoping that there's some cancellation. We multiply the reciprocal and then do some cancellation. So that's method 1. Method 2 is try to maybe clear some fraction by multiply by the LCD by all the terms. So let me show you an example. So method 2, again the key here is that we're going to try to find the LCD of all the denominator and try to multiply by everything by the LCD and try to clear all the fractions. So there's a 1 here, there's an x here, there's an x here, there's an x squared. So the LCD of all these denominators is x squared. Again, that's the highest term. So I'm going to multiply everything, top and bottom, by x squared, so I can clear the denominator. So multiply the top by x squared. So again, this distribute in, and then this distribute in. And notice when I distribute in, the x squared will cancel the x at the bottom. This x squared will cancel these denominator. So we're basically clearing the denominators. So if I distribute, I notice that again, the x squared cancel with this x to give us x. This x squared cancel with this x to give you an x at the bottom here. This will cancel to give you a minus 3. So after all the cancellation, we get this term. Notice that after we multiply by the LCD, all the fractions are gone, and now we're left with something that doesn't have fractions. So this is no longer a complex fraction. Now we can do as before, factor out, and then try to cancel again. So notice the common theme in this class is definitely a lot of factoring. And factoring is such an important skill when you go on to pre-calculus or calculus, even advanced math, right? At the end of the day, you always have to need to do a lot of algebra before you can get your final answer. And factoring is going to come up over and over again. As we've seen since we had that lesson in factoring, we basically factor in every single problem so far. Okay, here's another example using method 2. Again, the attempt here is to try to clear the denominator. So w plus 3, w minus 3, w squared minus 9. In fact, if you factor this out, you get w plus 3, w minus 3. So that means that picking out the LCD means picking out the highest term, and that means that w squared minus 9 is the LCD because it contains this as a factor, this as a factor, and then this is just a 1. So this contains everything as factors, so it is the included itself, so it is the least common denominator, the LCD. And again, you can see that by just factoring this and see that to find the LCD, pick the highest term, w plus 3, no w plus 3, w plus 3, so you pick w plus 3, w minus 3, w minus 3, there's no w minus 3, so pick the higher, which is w minus 3. So this is the LCD. And now we're going to multiply everything by this LCD. And so multiply the top by the LCD. Again, when you distribute, things will cancel. In fact, this will cancel with that to clear this denominator. This will cancel with that to clear that denominator. And then this whole thing will cancel with this to clear that denominator. So there it is. Cancel this with that, this with this, and then at the bottom this will multiply in. There's no fraction here, so there's no cancellation. And when you multiply this in, this will cancel entirely with this thing. And so now we have to simplify. So again, this minus has to distribute into both of these. So simplifying that, I get negative 6 over w squared, which is my final answer. Okay, so that was a little bit more involved, but again, the key is all about just factoring and then clearing these fractions. Okay, thanks for watching.